Hi everyone, we are in Unit 8 volume, Day 3 notes, composite figures, and volume word problems. So we're going to get started with number 1. The Great Pyramid of Giza was constructed as a regular pyramid with a square base. It was built with an approximate volume of 2,592,276 cubic meters. I'm underlining the important information, and a height of 146.5 meters. What is the length of one side of the base to the nearest meter? So first thing I'm already noticing is everything's in terms of meters, so I don't have to do any conversions. All right, so it is a pyramid. So I am going to go to my reference sheet and look up the volume of a pyramid, 1/3 big B H. So we have a pyramid. Volume equals 1/3 capital B H. All right, so I'm going to start to substitute in. They gave me the volume, so I'm going to replace the volume with 2,592,276. That equals 1/3. Big B, which we don't know, and then the height is 146.5. So pretty much we're going to be solving for capital B. So we have to do this work backwards. We're going to have to solve for B. There's two different ways you could start this. You could remove the 1/3, which is essentially just dividing by 3. You could multiply both sides by 3. I think I'll start with that. All right, so I'm just going to get a different color to show you what I'm doing. So I'm multiplying both sides of the equal sign by 3. That will then cancel out this dividing by 3. So on the right-hand side, I still have capital B times 146.5. And now this number is going to get bigger. So now I'm doing 3 times 2,592,276. Okay, so I now have this huge number, 7776828. All right, now to solve for capital B, I'm going to divide both sides by 146.5. So I'm taking my calculator, hitting divide 146.5. All right, so now I have 53084.15017 equals capital B. Capital B means the area of the base shape. And they told us it was a square base shape. So, a little information you need to know about a square. You know, the area of a square, we've been using the formula for parallelogram, which is B times H, base times height. But in a square, you need to know all the sides are congruent. So essentially, it is just referring to the square root of this number. So I'm going to do the square root, and I'm going to press some fancy buttons here, so it's taking my answer from above. All right, and then it said to the nearest meter. So, and this is multiple choice, so that'll be 230. Choice 4. So if they give you the volume, you're still going to choose the correct formula, you're still going to check your units, and you're going to substitute in your values. You may just have to solve your given equation. All right, so next we're going to talk about composite figures. So a composite figure is a shape that's made up of other shapes. Dissection is when you break up a composite figure into smaller shapes, just like you're dissecting a frog. You're taking a frog and you're breaking it up into smaller pieces. Same type of thing. So we're going to take a composite figure and break it up into recognizable shapes. Then we're going to find the volume of each shape and then add all the volumes together to find the total volume of the composite figure. So problem 2 says use dissection to find the volume to the nearest hundredth. Okay, so before I do anything, I'm checking my units. I have meters, centimeters, centimeters. They are not all the same. So this is metric system. So I'm using my metric conversion chart here. Since two of them are already in centimeters, I want to switch meters to centimeters, so I'm starting here at meters. I have to go 2 places to the right. So that 0.12, I'm going to go 2 places to the right, and this is going to be the same as 12 centimeters. So I'm no longer using that one value. All right, so everything's in the same units. So now I'm going to just look at the shape. I am seeing prism type shapes because I am seeing a base shape, and then here's another base shape that are parallel and congruent. So it's definitely, this whole thing is definitely some type of prism, but it's no prism I recognize. So I'm going to start to chop this up into recognizable figures. So right here, if we kind of removed all of that, we have a triangular prism. So that is like one composite figure that's here. Now next to it is a square prism or a rectangular prism if I draw this line. So if I kind of get rid of that, right here is like a rectangular prism. And then there's actually a third piece, which this drawing's kind of weird. I actually think there should be kind of like a segment drawn back here. It looks kind of weird. It looks like it's not drawn completely. But there is actually half of a cylinder back here. I mean, it's kind of hard to see. I don't know if that kind of helps. It's hard to see. There's half a cylinder. So technically there are 3 shapes here. So we are going to have to find the volume of all 3 and add them up. So the volume of the entire thing consists of half a cylinder plus a rectangular prism plus a triangular prism. Alright, so now I'm going to go to my reference sheet. So a cylinder is pi r squared times h, but we want half of it. Alright, the rectangular prism is capital B times h. And the triangular prism is also going to be capital B times h. Now these formulas I can get more specific because for a rectangular prism I'm going to need the area of this base shape, which is a rectangle, but I'm going to use the formula for a parallelogram. So it's actually, I'm going to be doing the base of the parallelogram times the height of the parallelogram, but then times the height. Remember, this is a different height. That's going to be the height of the three-dimensional shape, the prism. And the triangular prism is a triangle, so that's 1/2 base times height, and again times the height. This height is different from that height. This height in the volume formula refers to the distance between your 2 congruent parallel bases. So here's all of my formulas. So I'm going to substitute in. Maybe I'll just do a cylinder first. Cylinder, I need the radius. So I'm looking at the picture. I know radius is halfway across a circle. Now, are you guys aware radius can go any direction? So what I'm actually looking for is this, which I notice this side's parallel to it, and that's 6 centimeters. So this is going to be half of that. This is going to be 3 centimeters. So I'm going to leave my half. I need my pi. My radius is 3 centimeters. And then the height of this whole prism is that 12 centimeters. Alright, this shape in the middle, it is a rectangle, so I need this number times that number. I have 6. I'm noticing a tick mark here and a tick mark there. That means they're congruent, so that one's 4 centimeters. So I have this base 4 times this height 6 of the rectangle, and then I need to multiply by the height of the entire prism, which is my 12. And then for my triangle, I need the formula 1/2. I need the base of this triangle, which is 4. I need the height of that triangle, which is 6. And then the height of the whole prism, which is 12. So now I'm just going to go to the calculator and carefully type all this stuff in. I think I'm going to do one piece at a time. So 1/2 times pi times 3 squared times 12. All right. 169.6460. Remember, go up 4 places. Then 4 times 6 times 12. That's 288. Then I have 1/2 times 4 times 6 times 12 is 144. Now I'm going to add those all together. So I've got my 169.6460 plus 288 plus 144. All right, so total volume. So this should volume. So volume of the whole composite figure is 601.646. I want to check nearest hundredth. So we have to round 601.65. My units were all centimeters, so centimeters cubed. So there we go. That's how you find the volume of a composite shape. All right, let's flip. All right, this problem says, sometimes we need to find the volume of a larger shape and a smaller shape and then subtract the two volumes to determine the remaining volume. So if you check out problem 3, 2 tennis balls fit exactly in the 48 centimeter tall cylindrical can. What is the volume of the air in the can? And then follow-up question, what percent of the can is not filled with tennis balls? So this problem, I have only one unit of measurement, centimeters, so I don't have to do any conversion. So I'm noticing I have a cylinder. All right, and I notice I also have spheres. I have 2 spheres. So pretty much I'm thinking I need to take the volume of the cylinder and subtract the volume of the 2 spheres, and that'll give me how much air is in the can. All right, so I'm going to my reference sheet. Cylinder is pi r squared h, and then I have 2 spheres, and the formula for a sphere is 4/3 pi r cubed. All right, so I'm going to start substituting in. All right, r, I need the radius. I don't have a radius. So you got to do some thinking here. 48 is the height of the can. So 48 is also right here. That's 48 inches. There are 2 identical tennis balls, so 48 divided by 2 gives you 24. So the diameter of each of these is 24 centimeters, which then means the radius is going to be 12 centimeters for each tennis ball. So I'm now going to substitute in my 12 for my radius, and then I need the height of the whole canister, which is 48. Then minus 2 times 4/3 pi, and my radius again is 12 cubed. All right, calculator time. We need pi times 12 squared times 48. This value, 21714.6884. All right, so this one, it looks crazy to type in. You're just doing 2 times 4 divided by 3 times pi times 12 to the 3rd power. So I'm using my caret button. I'm raising that to the 3rd power. All right, so this is 14476.4590. I had to round. All right, so let's subtract these. 21714.6884 minus 14476.5490 gives me 7238.2294. Directions said just what's the volume. It actually didn't say to round or do anything, so we're going to leave it like that. That is centimeters cubed. That's our volume. All right, this video is about to end, so I'm going to stop now, and then I'll start up a new one, and we'll finish this question. Okay, bye.